There are more stars in the universe than there are grains of sand in all the beaches on the Earth. That's a spectacular, phenomenal thought. And we're just starting to learn about planets now that are orbiting other stars. And there are now upwards of 450 of those planets known. And we're discovering multiple planet systems. So it's quite possible that there are more planets even than stars in the universe.
For the 40 years or so or more that I've been doing astronomy, there has been one excitement after another, one brand new puzzle to solve. Our latest is the mystery of dark energy, which makes up 73% of the mass and energy content in the universe. There's dark matter, which has a longer heritage, that makes up 20-something%. We know nothing about dark energy. We know a little about dark matter. The stuff that we know a lot about, the ordinary material that you and I are made of, is a mere 4%. So I see the Giant Magellan Telescope in its broadest sense of helping us to figure out more about the 4%, but also a lot about the 96% that is dark, of which we know very little.
The GMT, because it has such a large mirror, can see exquisite detail, much more than any of the current technology.
In the history of science, every time that we've built a new, bigger telescope, we've made major discoveries that no one could have possibly anticipated, complete surprises, and the GMT is the next step in that progression.
The sheer size of it allows you to get better spatial resolution. That means you can detect finer spatial detail. You can see things that are closer together more precisely.
The Giant Magellan Telescope will be able to produce images that have 10 times the resolution of the Hubble Space Telescope. So what that means for my research is that I'll be able to image black holes that are closer together than we've ever been able to see before.
And the extra light gathering power, the extra spatial resolution that GMT offers, and the capabilities of the instruments we plan to build will push us into an era where instead of simply detecting young planetary systems, we're actually studying these systems and really understanding how systems like our own solar system, or systems that we never could have imagined before, are coming into being and how they will evolve over time.
Most of my data has come from the Hubble Space Telescope. That has been a tremendous boon for black hole research because it allows us to get away from Earth's atmosphere and we don't have the blurring of the Earth's atmosphere. What is special about the GMT, and what's special about the GMT compared to the other proposed large telescopes like the GMT, is that it should be able to compensate for the atmosphere much better than any of them. And in fact, it vastly is superior to HST and the other telescopes. So in terms of trying to probe the detail that you need to get close to the black hole, the GMT is superior, and that's one of the reasons why I'm so big on the GMT.
McDonald Observatory is a good astronomical site. We observe about 2/3 of the nights in a year, but it is not the best site in the world. Chile has many more clear nights. The atmosphere is much more stable. The image quality of stars and galaxies is much higher, and one gets a better return on your huge investment by putting the telescope at what is a very, very good site.
This will be a paradigm shift in what we understand about the universe, about galaxies, and about life. We want Texas to be the leader in this endeavor.
A key to having a first-rate department is to have the absolutely best faculty you have. And faculty members, especially when they're young, are extremely mobile, and they're interested in going places where the best research opportunities are, where they have a chance to make an impact on the field. And those kind of opportunities exist in places where there's first-rate instrumentation available to them.
We really want to be on this leading cutting edge of doing the research instead of sitting back and letting other people do it and then sort of trying to fill in the little details. And so that's what we're driving for here, is to be leaders in the world, not just followers.
With access to the Giant Magellan Telescope, we shall be one of the very few astronomy programs with access to very large telescopes that can probe the frontiers of observational astronomy.
That'll help us tremendously in recruiting new students and postdocs and faculties to come to UT, because we can offer them this observational resource that nobody else can.
One of the major motivations for doing this type of work is trying to answer the question, is there life elsewhere in the universe?
The GMT offers the possibility of making real breakthroughs in our understanding of the formation and early evolution of planets.
The 21st century is poised to be, I think, a new golden age in astronomy. And I think the Giant Magellan partners, we are now poised to address those new questions. And it's a very exciting opportunity.